This video is on solving by complete the square. So we're going to look at this through an example. I'll write the steps out as we do it. But the important thing is that understand solving by complete the square is really the way of writing one side as a perfect square trinomial, so then you can write it as a factor that's a perfect square, so you can use the square root property. So that's really the goal in what we're going to do. I'll write the steps and then we'll see what happens as we go through it. So for this one here, we're going to solve by complete the square. The x squared minus 8x plus 34 equals 0. Now, if I tell you to solve using a certain method, you have to use the method I described. Otherwise, you can use any method you prefer. But if I ask you to solve by complete the square, you need to use complete the square. So the first steps. The first thing you want to do, right, this is for solving quadratics, so we have x squared here, right, or the first variable to the second power. But you want to make sure that the leading coefficient, the number in front of that, is always 1. So the first thing is make sure the leading coefficient is 1. Right? And which means you typically won't see a value there, right? Because if we don't see a value, then there's a 1 there, right? This is like 1x squared. So in this case, we have that. If we didn't, you'd have to divide everything by whatever the coefficient was to make it 1. And we'll talk about that a little bit later. Second step, you're going to rewrite the equation so that the constant is isolated on one side. So you have these quadratic equations that have the highest power of 2, and the idea is that you want the constant on the other side and everything that has variables on the opposite. So you know the equation we had was the x squared minus 8x plus 34 equals 0. It's just me rewriting the first one. So what I'm going to do is I'm going to subtract 34 from each side to get the constant on the opposite side of where the variables are. So notice with this, x squared minus 8x equals negative 34. Now this is where we're going to actually do our complete the square process. My goal is to make this left side a perfect square trinomial. So when I factor it, it's the same factor times itself, meaning it's a factor squared. And the way we do this is actually we do it systematically. If you take 1/2 of the middle coefficient, so the coefficient on your x here. Alright, so 1/2 of the middle coefficient, and you square it. Okay, so we're going to take half of the negative 8, and we're going to square it. What we're going to do with this is we're going to add this to both sides. And you have to add it to both sides because that's what keeps it balanced. Right? So add this to both sides of the equation. So what I really have is this. I have, x squared minus 8x plus, I'm going to put a blank here. It kind of helps me remember what I'm going to do. I'm going to add to both sides, is equal to negative 34 plus a blank. And so what I want to do is I want to take half of whatever the middle coefficient is, right? Square that, and then I'm going to add that value to both sides. Now I'm going to write this out, and it's going to be important you write it out for yourself because it'll be easier to see what happens in the following examples. But taking 1/2 of negative 8. Now you might be able to do this in your head, right? So 1/2 of negative 8, and then we're going to square that value. All right, so we're doing 1/2 of negative 8, and then we're squaring it. So make sure you do the 1/2 of negative 8 first. 1/2 of negative 8 is really the same as negative 8 divided by 2. So this would be equal to negative 4, and that's getting squared. And what's negative 4 squared? Well, that's equal to positive 16. Now this will always be positive because if it's a negative squared, it'll be positive. If it's a positive squared, it'll be positive. So that's why we know we can add it to both sides as a plus. So what it's saying is take half the middle, half of negative 8, and then square it. So half of negative 8 is negative 4 squared gives us positive 16. We're going to add this to both sides. So 16 here and 16 here. And now what you're going to do, right, and really you'll see it in the next step, is now that you've done this on your left side here, you've created a perfect square trinomial. In other words, if I was to factor this, right, this would factor to what? Well, x squared tells x times x multiplies with a positive 16, adds with a negative 8. Well, it's negative 4 times negative 4, which really means that this side is really x minus 4, the quantity squared. That's what we're talking about when we say complete the square. On the right side here, you just add these together. Negative 34 plus 16, well, that's going to be a negative 18. So you end up with x minus 4 squared equals negative 18. The point being, though, is that you could really jump from this right to here, because when you say take half of the middle term, square it, and then add it to both sides, this will always factor down to whatever the half of the middle coefficient was, right? That's what you're going to be adding or subtracting inside of here. So it'll be x minus 4 and that quantity squared. So it really gives you what your factors are going to be if you write it like this and understand that this, whatever you were squaring here, right, half of the middle coefficient is what's going to be actually being added or subtracted inside. On this side, you have to, figure out what the value was and just add them together. So step 4, right, is to, and we just did it above, but I'll do it on the next page. All right, so step 4 would be to rewrite, no, put 4 here, step 4. Step 4 is to rewrite the left side as a perfect square and combine like terms on the right side. So that's what I just did here, right at the bottom here. I wrote this side as a perfect square, and I combined like terms on the right side. Now here I showed it by factoring. We don't have to show that factoring every time. You're not going to want to, because if this number is a fraction, it might be complicated to see or kind of confusing to see. You really just want to be able to jump to here and say, I know it's going to be a perfect square factor, and that x minus or plus whatever the value was when I took half the middle coefficient. So this is really, right, our step 4 is right there. I'll write it up here just so we see it again. So we have this x minus 4 squared equals negative 18. You should know how to solve this. We've seen in the past that if you have a perfect square on one side equal to a constant, you're trying to solve for that variable. We use the square root property, right? So now we use, so I'll say solve this by using the square root property, which really means you're taking the square root of each side. So I have x minus 4 squared is equal to negative 18. And when I take the square root of each side, remember how this works. When I take the square root, I have to write plus or minus in front. Don't forget that, because remember, you're going to get 2 answers when you do this. So I'm left with x minus 4 is equal to plus or minus the square root of negative 18. Now before we isolate x, let's simplify the square root of the negative 18. So I have x minus 4 equals plus or minus the square root of a negative, tells you can factor out an I. 18 is not a perfect square, but you can break it down to its highest perfect square factor and a non-perfect square factor. Highest perfect square is a factor of 18 is 9. The non-perfect factor would be 2. Simplifying this, I have x minus 4 equals plus or minus square root of 9 is 3, so this will be 3i radical 2. And then we'll add 4 to each side. So we get x equals, now remember how this works, it's 4 plus or minus, it's a positive 4, so it's just 4 plus or minus 3i radical 2. These aren't like terms, you can't combine them, they're not like radicals, so you can't combine those together. But make sure you understand you have 2 answers here, right? This is, if I was to write it as a set, right, it's 4 plus 3i root 2 and 4 minus 3i root 2. So these are your answers right here. Right, two solutions, and these are the answers that make this true. They're the x values that would make this original equation true. In the past, when you saw this, you'd try to factor it, but if you were trying to factor this, numbers that multiply to 34 and add to negative 8, those don't exist with, integer values. So, this gives us the solutions that come out to complex solutions, right? We have imaginary pieces in there, but that's okay. It still works out. So, you could use this to solve any quadratic. Typically, if it's something that factors, we'll factor it. But if it's something that doesn't factor, you would want to try to solve by complete the square. If I tell you to use solve by complete the square, though, you have to use this method. Let's take a look at another example here. So if I said to solve by complete the square. And we'll look at, how about this one here. Let's say 2x squared minus 7x minus 3 equals 0. Now first off, I'm telling you to solve by complete the square, so you shouldn't try to factor or anything like that. If I didn't tell you to solve by complete the square, you might want to try to factor it. But since we're saying solve by complete the square, we got to follow our process. And step one was, don't forget it, because it's really important. Make sure that the leading coefficient is 1. In this case, the leading coefficient isn't 1. Right? In this one that we did previously, it was, so I didn't have to do anything. But if the leading coefficient isn't 1, it doesn't mean all is lost. It means, how do you make that look like a 1? Well, you divide by whatever the coefficient is. So I'm going to divide by 2, but you have to divide it to every term. Right, so I'm going to divide every term by 2 here. And then I end up with, this becomes just x squared, right? The 2's cancel, minus 7 over 2 times x, or 7/2 x, minus 3 over 2, and I'd keep these as fractions, equals 0 divided by 2, which is 0. So these are equivalent. We just divided each side by 2, and now the leading coefficient is 1. Now remember what you want to do. You want to get the constant on one side of the equation and the parts of the variables on the other. So your next step would be to add 3/2 to each side. I end up with x squared minus 7/2 x is equal to, on this side, 3/2. And if you remember what I did before, I like to put this blank here because we know we're going to be adding something to each side. So plus a blank and plus a blank, because this is where we're going to use our complete the square step in the next step. So if you do it now, so you have it there, it's kind of helpful, right? So we have x squared minus 7/2 x plus whatever we are going to do with the square is equal to 3/2 on the side plus that same blank, right? So we move the constant to the other side, and now we're just going to figure out how to fill in for that. Remember how you fill in, right? How do you complete the square? Well, you want to take 1/2 of the middle coefficient and square it and add that to both sides. Now it's a fraction this time, so don't let that throw you off. 1/2 of the middle coefficient, which is negative 7/2, and we want that quantity squared. Well, let's simplify the inside first. 1/2 times negative 7/2, you multiply fractions, remember, straight across the top, straight across the bottom. So numerators, 1 times negative 7 would be negative 7 over 2 times 2, which would be 4, and then we're squaring that. And if I square this, a negative squared makes it positive. 7 squared in the numerator is 49 over 4 squared in the denominator is 16. So I'm going to add 49 over 16 to each side. That's me completing the square here. All right, so making sure your leading coefficient is 1, get the constant to the other side, and then we complete the square, taking half the middle coefficient and squaring it. So it's 49/16 that I'm adding to each side. And you have to do it to both sides because it's what keeps it balanced. Sometimes people do it to this side and they forget to do it to this side. That's why I put both the blanks there, so you remember you fill in for both of them at the same time. Now what do we do? Well, now we wanted to write the left side as a perfect square, right? So if I did this properly, this should be a perfect square trinomial. Now it may or may not be obvious to you that it is, but remember I said there's a little bit of a shortcut you can take, right? When you go to write the perfect square, right, it's always going to be x plus or minus whatever that middle coefficient is. So we have, in this case, x, and I should say plus or minus half of whatever that middle coefficient was. So whatever you squared. So it's going to be x minus 7/4 squared, right? Half of the negative 7/2, so it's negative 7/4. and it's going to be equal to, on this side we're going to add these together. When we add these together, alright, 3 halves plus 49/16. These are fractions, so we need a common denominator. So you want to rewrite 3 halves as something over 16, because we want to be able to add these together. 2 times what gives you 16? Well, 2 times 8 gives you 16, so 3 times 8 is 24 in the numerator. So we got 24 over 16, plus here 49 over 16 already is over the common denominator of 16. And then once you're here, you can combine like terms on the right side. On the left side though, let me just kind of show you why this works. The x minus 7/4 squared. Now I'm going to do this as an aside over here, just so you can see that what I'm telling you is actually true. Like, you could just kind of memorize that it's always going to be half of the middle, but you should understand that the reason is because this should factor to x minus 7/4 times x minus 7/4. That's what this trinomial factors to, and that's how I can write squared. So what I'm really going to do here is to show you that this really does equal this. So if I square this, alright, distributing through, I get x times x is x squared, x times negative 7/4 is negative 7/4 x, negative 7/4 times x is negative 7/4 x, negative times a negative makes a positive, 7/4 times 7/4, numerator times numerator, 7 times 7 leaves 14. 4 times 4 is 16 in the denominator. When we add these, we have x squared, negative 7/4 minus 7/4 is going to be negative. Don't cancel those. It gets more negative because they both have the same sign. It'd be negative 14/4 x plus 49/16. And then reducing the 14/4, we have x squared minus 7 halves x plus 49 over 16, which is what it should have been, right? That's what we said. This factors down to this. So the shortcut to factoring this is just knowing it's going to be x and then whatever this is. Either if it's negative, use negative. If it's positive, use positive. It always comes from whatever that same sign is for the middle coefficient, and it's half the middle coefficient, right? Half of the middle coefficient. So it's x minus 7/4 squared. So that's why we can shortcut that, because it's really how it factors. But it's not obvious. If I just asked you to factor this without telling you this information, it might not be obvious to you how it factors out. Alright, so let's combine like terms on the right side. So I'll leave the left the same. So x minus 7/4 squared equals, on this side here, 24/16 plus 49/16. Remember, it's all over 16. 24 plus 49 gives you 73. You can do that in a calculator if you need to. And then, now remember how we solve. We solve by square root property. So we want to get to x, remember. So square root of each side. If I take the square root, I have to write plus or minus. Don't let it throw you off. This is a fraction. You still take the square root of the whole thing. So we have x minus 7/4. Remember, when you take the square root of something squared, it's just the inside. It's equal to plus or minus. Now, remember, if you have a fraction here, right, if you have division or multiplication inside of a square root, you can really take the square root of each piece individually. Square root of 73 over the square root of 16. And that simplifies, right? So we end up with x minus 7/4 equals plus or minus. Now the square root of 73, it's not a perfect square, and it doesn't have any perfect square factors because 73 is prime, so it's just plus or minus square root of 73 over, taking the square root of 16 though, we can take that square root. Square root of 16 comes out nicely to 4. And then now we're ready to solve, so I'm going to add 7/4 to each side. Add 7/4 to isolate x, so we have x equals, we've got 7/4, because that's positive, plus or minus the square root of 73 over 4. Now this is two answers. Now you could leave it like this. Because these have a common denominator, you could actually write it as x equals 7 plus or minus the square root of 73 all over 4. When you add or subtract fractions of the common denominator, you add or subtract the numerators, keep the denominator the same. So this is the same answer as that. Or you could write it as two answers, 7 plus the square root of 73 over 4, and 7 minus the square root of 73, all over 4. Now remember, we're allowed to do this because we have a common denominator. If you don't have a common denominator, you can't write them over the same denominator, right? They already had the common denominator of 4, so I was able to write them like this. But it's two answers. Make sure you have two solutions there. These are the values for x that make this original problem true. Which really kind of tells you something. If you were to factor this, you couldn't factor it nicely. because these would come out to integer values if you could, right? If you were to try to factor this, you would want things, if you used the AC method, that multiply to a -6 and add to a -7, and there aren't numbers that do that, even though it might feel like there are. So this is where solve by complete the square really can kind of help us out. Why don't we stop this video here, and I'll do one more video where we do a couple more examples.